The road to recovery after a stroke is a challenging one, often marked by significant cognitive and physical hurdles. For many seniors, regaining mental acuity, memory, and energy becomes a primary focus. But what if there was a powerful natural ally, often overlooked, that could significantly support this intricate process? Today, we delve deep into the remarkable world of vitamin B complex, not just as a general health booster, but as the brain's ultimate ally in post-stroke recovery, particularly for individuals aged 50 and above. We'll explore how these vital nutrients can rebuild, restore, and rejuvenate neural pathways, transforming the recovery journey. Consider Arthur, a retired architect from New York, who after his stroke found himself grappling with profound memory lapses and a pervasive lack of focus. Overwhelmed by the sheer volume of information on post-stroke nutrition, he embarked on a dedicated quest to understand the 9 essential vitamins that boost brain recovery after stroke. His journey, which we will follow today, illuminates the profound impact targeted nutritional strategies can have. Before we unravel the specific benefits of B vitamins, it's crucial to understand the landscape of post-stroke brain recovery. A stroke or cerebrovascular accident occurs when blood flow to a part of the brain is interrupted, leading to brain cell death. The aftermath can manifest in a myriad of ways, from motor skill deficits and speech difficulties to most profoundly cognitive impairments, such as memory loss, reduced executive function, and difficulty with information processing. The brain, however, possesses an incredible capacity for neuroplasticity, its ability to reorganize itself by forming new neural connections. This inherent resilience is what makes recovery possible, but it demands optimal conditions and robust nutritional support. For seniors, this process can be particularly challenging due to age-related physiological changes that may affect nutrient absorption and metabolic efficiency. Arthur, for instance, found that his post-stroke fatigue wasn't just physical. It was a deep mental exhaustion that made even simple tasks daunting. His initial consultations highlighted the importance of a comprehensive recovery plan, emphasizing not only physical therapy, but also advanced nutritional strategies. He realized that merely surviving a stroke was one thing. Thriving afterwards required a proactive and informed approach to his brain's intricate needs. The B vitamin complex is a group of 8 water-soluble vitamins that play critical interconnected roles in cellular metabolism. Unlike fat-soluble vitamins, B vitamins are not stored in the body for long periods, necessitating a consistent dietary intake. While each B vitamin has its unique functions collectively, they are indispensable for optimal neurological function. They act as coenzymes in numerous biochemical reactions, particularly those involved in energy production within brain cells, the synthesis of neurotransmitters, the chemical messengers that allow brain cells to communicate, and the maintenance of nerve cell integrity. Imagine the brain as a complex electrical grid. B vitamins are the essential components ensuring the power flows smoothly, the signals are transmitted clearly, and the wiring remains intact. After a stroke, when the brain is in a state of repair and heightened metabolic demand, the availability of these cofactors becomes even more paramount. A deficiency in even one B vitamin can have cascading negative effects on cognitive function, mood, and overall neurological recovery. This holistic synergy is precisely what captivated Arthur as he delved into the research. He understood that a targeted approach wasn't about one magic pill, but a comprehensive strategy where each B vitamin contributed to a greater symphony of healing and restoration. Let's begin our deep dive with vitamin B1 or thiamine. Thiamine is absolutely vital for glucose metabolism, particularly in the brain, which relies almost exclusively on glucose for energy. Without sufficient B1, the brain's energy factories, the mitochondria, cannot function efficiently, leading to a profound energy deficit in neural cells. This can exacerbate post-stroke fatigue and impair cognitive recovery. Thiamine also plays a direct role in nerve impulse transmission and the synthesis of neurotransmitters like acetylcholine, which is crucial for memory and learning. After a stroke, damaged brain cells are already struggling, and a lack of B1 can significantly hinder their repair and regeneration efforts. Studies have shown that thiamine deficiency is more common in older adults and those with chronic conditions, making supplementation a critical consideration for stroke survivors in the senior demographic. Arthur learned that even mild thiamine deficiency could mimic stroke symptoms or impair recovery, prompting him to carefully assess his intake. He started focusing on whole grains, lean meats, and legumes, foods rich in B1, as a foundational step in his dietary adjustments. Next, we examine vitamin B3 or niacin. Niacin is a powerhouse involved in over 200 enzymatic reactions crucial for DNA repair and cellular signaling. Its role in energy metabolism is profound, as it's a key component of NAD and NAD coenzymes essential for converting food into energy. For stroke recovery, niacin's anti-inflammatory properties are particularly valuable. Inflammation is a significant factor in secondary brain damage after a stroke, and B3 can help modulate this response, protecting neural tissue. Furthermore, niacin has vasodilatory effects, meaning it can help widen blood vessels, potentially improving circulation to areas of the brain that may have compromised blood flow. While high doses of niacin are sometimes used to manage cholesterol, its neuroprotective benefits at appropriate supplemental level are increasingly recognized in post-stroke care. Arthur, initially cautious about any supplement, learned that the flushing effect often associated with the niacin could be managed with specific forms or lower doses, and the potential benefits for brain circulation and inflammation were too significant to ignore. He discussed this extensively with his neurologist, who agreed to incorporate a carefully monitored niacinamide, a non-flushing form of B3 supplement, into his regimen alongside dietary sources like chicken, tuna, and mushrooms. Vitamin B6 or pyridoxine is another critical player in brain health, particularly after a stroke. Its primary role in the nervous system involves the synthesis of several key neurotransmitters, including serotonin, dopamine, norepinephrine, and GABA. These neurotransmitters are vital for mood regulation, sleep, cognitive function, and stress response, all areas frequently impacted by stroke. A balanced supply of these chemical messengers is essential for restoring neural communication and supporting psychological well-being during recovery. Beyond neurotransmitters, B6 is also crucial for the metabolism of homocysteine. Elevated homocysteine levels are a known risk factor for stroke and can contribute to vascular damage and neurotoxicity. By working with B9 and B12, B6 helps convert homocysteine into other beneficial compounds, thereby reducing its harmful effects. This homocysteine regulation is a cornerstone of B vitamin therapy in cardiovascular and neurological health. Arthur noticed his mood swings were less severe, and his sleep patterns began to stabilize a few months into his recovery. While many factors contributed, his care team highlighted the potential role of his balanced B vitamin intake, particularly B6, in supporting these improvements. He continued to prioritize B6-rich foods like bananas, potatoes, and salmon. Vitamin B9, known as folate in its natural form, and folic acid in its synthetic form, is indispensable for DNA synthesis and repair cell division in the formation of red blood cells. In the context of stroke recovery, these functions are paramount for regenerating damaged brain tissue and supporting overall cellular health. Folate is also a critical cofactor in the methylation cycle, a fundamental biochemical process involved in numerous bodily functions, including detoxification and neurotransmitter production. Crucially, like B6 and B12, folate plays a central role in regulating homocysteine levels. Elevated homocysteine is a potent neurotoxin and vascular irritant, directly contributing to neuronal damage and increasing the risk of recurrent stroke. Ensuring adequate folate intake is a proactive measure against these risks. For seniors, malabsorption can be an issue, making supplementation often necessary, especially for those with specific genetic variations that impair folate metabolism. Arthur learned about the importance of the methylated form of folate, L-methylfolate, for better absorption, particularly for individuals with MTHFR gene mutations, which are relatively common. He incorporated leafy green vegetables, citrus fruits, and fortified grains into his diet, carefully monitoring his intake to ensure optimal levels as advised by his nutritionist. Finally, we turn our attention to vitamin B12, or cobalamin, a nutrient of particular concern for seniors. B12 is indispensable for the formation of myelin, the protective sheath around nerve fibers that allows for rapid and efficient nerve impulse transmission. Damage to myelin can lead to impaired neurological function, a common consequence of stroke. By supporting myelin repair and maintenance, B12 directly contributes to the restoration of neural pathways. Furthermore, B12 is vital for red blood cell production, ensuring adequate oxygen delivery to the brain, which is crucial for recovery. Like B6 and B9, B12 is a key player in the metabolism of homocysteine, making it a triad of vitamins essential for cardiovascular and brain health. What makes B12 particularly relevant for seniors is the high prevalence of deficiency in this age group, often due to decreased stomach acid production, which impairs B12 absorption and the use of certain medications. Symptoms of B12 deficiency can mimic those of stroke or dementia, including memory loss, confusion, and fatigue, making accurate diagnosis and supplementation critical. Arthur's initial blood test revealed a borderline B12 deficiency, a common finding for someone his age. His medical team immediately recommended a B12 supplement, initially through injections and later as a sublingual form. This intervention, he felt, was a turning point in his mental clarity and energy levels, allowing him to return to his cherished hobby of sketching cityscapes with renewed vigor. While whole foods should always be the primary source of nutrients, achieving optimal B vitamin levels, especially after a stroke, can be challenging through diet alone. Let's explore both. For B1 thiamine, focus on lean pork, whole grains, fortified cereals, legumes, and nuts. B3 niacin is abundant in poultry, fish, tuna, salmon, beef, mushrooms, and peanuts. B6 pyridoxine can be found in poultry, fish, potatoes, bananas, and fortified cereals. B9 folate is plentiful in leafy green vegetables, spinach, kale, asparagus, broccoli, citrus, fruits, and beans. Finally, B12 cobalamin is almost exclusively found in animal products like meat, fish, poultry, eggs, and dairy. Fortified plant-based foods can be an option for vegetarians, vegans. Now, regarding supplementation, this is where personalized medical guidance becomes paramount. For stroke survivors, particularly seniors, factors like impaired absorption, medication interactions, and increased metabolic demands often necessitate targeted supplementation. Arthur's journey exemplifies this. After his B12 deficiency was identified, his doctor prescribed specific forms and dosages. When considering a B-complex supplement, look for products that contain methylated forms of B9L methylfolate and B12 methylcobalamin or adenosylcobalamin, as these are more bioavailable, especially for individuals with genetic variations affecting metabolism. Dosage must always be determined by a healthcare professional based on individual needs, blood test results, and overall health status. Self-medicating with high doses of B vitamins can be counterproductive and in some cases harmful. Arthur regularly reviewed his supplement regimen with his neurologist and a registered dietitian, ensuring his intake was perfectly calibrated to his evolving recovery needs. Beyond the basics, there are advanced considerations and common pitfalls to avoid when leveraging B vitamins for stroke recovery. Firstly, interactions with medications. Certain medications commonly prescribed to seniors can interfere with B vitamin absorption or metabolism. For example, proton pump inhibitors, PPIs for acid reflux, can reduce B12 absorption, and diuretics might deplete B1. Always inform your healthcare provider about all medications and supplements you are taking. Secondly, homocysteine levels. We've mentioned this before, but it bears repeating. Monitoring and managing homocysteine levels is a critical biomarker for stroke risk and recovery. A simple blood test can reveal elevated levels, and a targeted B6, B9, and B12 regimen can often bring these levels down, significantly reducing future vascular risk. Thirdly, synergistic nutrients. B vitamins don't work in isolation. Their efficacy is often enhanced by other nutrients. Magnesium, for instance, is a cofactor for many B vitamin-dependent enzymes. Omega-3 fatty acids, particularly DHA, are crucial for brain structure and function and work synergistically with B vitamins to support neural repair. Lastly, let's address common mistakes to avoid. 1. Self-diagnosing and megadosing. Never assume a deficiency or take extremely high doses without medical supervision. Excessive intake of some B vitamins can have adverse effects. 2. Ignoring diet supplements are meant to supplement a healthy diet, not replace it. A diverse, nutrient-rich diet remains the cornerstone of health. 3. Not monitoring progress. Regular blood tests to check B vitamin levels and homocysteine with cognitive assessments are essential to tailor the regimen and track improvements. Arthur's disciplined approach, always under the guidance of his medical team, allowed him to navigate these complexities. He understood that his recovery was a marathon, not a sprint, and that informed decisions were key to his sustained progress. His commitment to understanding his body's unique needs, guided by his doctors, led to his remarkable cognitive improvements, truly making the B complex his brain's best friend. In summary, the journey to recovery after a stroke is multifaceted, and optimal nutrition, particularly a targeted approach to the B vitamin complex, stands as a cornerstone of neurological restoration. We've explored how B1 supports brain energy, B3 aids in DNA repair and circulation, orchestrates neurotransmitter synthesis. B9 is crucial for cellular regeneration and homocysteine management, and B12 is indispensable for myelin health and oxygen delivery. Arthur's remarkable progress underscores the profound impact these brain's best friends can have when integrated thoughtfully into a comprehensive recovery plan, always under expert medical guidance. These powerful micronutrients are not just vitamins. They are vital cofactors in the symphony of brain repair, helping to rebuild neural pathways, enhance cognitive function, and restore vitality for seniors navigating the post-stroke landscape. If you found this in-depth guide valuable, please give this video a thumbs up, share it with someone who might benefit, and subscribe to CareWiseSenior for more expert insights into healthy aging and post-stroke recovery. Your engagement helps us bring vital information to more seniors like Arthur. And speaking of vital information, our next video will delve into another crucial nutrient, vitamin D deficiency, the hidden stroke risk after 50. Don't miss it. Thank you for joining us on CareWiseSenior. Remember, knowledge is power, especially when it comes to your health. Stay informed, stay proactive, and empower your journey to a vibrant, healthy life. We'll see you in the next video.